The universe might be a thought you're having. What if this very moment, the light hitting your screen, the sound in your ears, the solid ground beneath your feet, isn't real? At least not in the way you think it is. What if the entire universe with its billions of galaxies and mind-boggling distances isn't something you are in, but something you are doing? A colossal, intricate thought that you, yourself, are having right now. That idea sounds like it was ripped straight from the pages of science fiction, or maybe an ancient philosophical text. And honestly, that's mostly where it's lived. The standard story of our existence is pretty straightforward. 13.8 billion years ago, the Big Bang happened. Matter and energy burst into being, eventually clumping together to form stars, planets, and, after a very long time, us. In this version of events, the universe is a vast, pre-existing stage, and we're just the latest actors to walk onto it. Consciousness is just a cool trick that the brain, a squishy biological computer, learned how to do. But what if we've got the story completely backward? This is a journey into a radical, reality-bending thought experiment. We're going to explore a possibility that flips our understanding of everything on its head. The idea that the universe doesn't create consciousness, but that consciousness creates the universe. Now, to be crystal clear, we are venturing far from mainstream consensus science. The vast majority of physicists and neuroscientists are firmly behind the model of a universe that existed long before we did. But in the weird and wonderful borderlands where quantum physics and philosophy collide, some questions have popped up that are so profound, they force us to rethink what real even means. We're not looking for a final answer, but to explore the question itself. Section 1. The quantum riddle. Our journey starts in the strangest and most successful branch of science ever developed, quantum mechanics. Down at the subatomic level, the logical rules we rely on every day just completely fall apart. And nothing shows this better than the famous double-slit experiment. The setup is simple. You fire tiny particles, like electrons, one by one at a barrier with two skinny slits in it. Behind that is a detector wall that marks where each electron lands. If electrons were just tiny marbles, you'd expect to see two clean stripes on the back wall, right where they pass through the slits. And sometimes, that's exactly what you get. But here's where reality takes a sharp left turn. If you run the experiment without checking which slit each electron goes through, something bizarre happens. The electrons ditch their particle act and start behaving like waves. They seem to pass through both slits at once and interfere with themselves, creating a pattern of many stripes on the back wall, like ripples in a pond. The particle exists in a cloud of all possibilities at once, what physicists call a superposition. The truly baffling part is what happens when you decide to watch. If you place a detector at the slits to see which path each electron takes, the wave pattern instantly vanishes. The very act of measuring it seems to force the electron to pick a side, and the weird interference pattern is replaced by the two simple stripes you'd expect from marbles. It's tempting to say the particle knows it's being watched, but that's giving it a little too much credit. The mainstream physics explanation is that measurement is a physical interaction. The device you use to detect the electron inevitably bumps into it, breaking its delicate wave state. Observation here means a physical interaction, not necessarily a conscious mind. But this loophole, this measurement problem, is a crack in the door of reality, and some wild ideas have slipped through. Section 2. The conscious observer. If measurement is the key, what actually counts as a measurement, A machine? A cat? A person? This question led the brilliant physicist Eugene Wigner to cook up a thought experiment now called Wigner's Friend. Imagine your friend is in a perfectly sealed lab. Inside, they run a quantum experiment and see the result. For them, the particle's hazy wave has collapsed into a definite state. Reality is fixed. But for you, standing outside, you have no clue what happened. From your point of view, the entire lab, your friend, the gear, the particle, is now one giant quantum system. As far as you're concerned, your friend is in a superposition of both seeing the particle on the left and seeing it on the right. So when does reality actually lock in? Does it snap into place for your friend inside? Or only when you open the door and ask them what they saw? This puzzle pushes quantum logic to its absolute limit and suggests that reality might be relative to who's looking. While it's a foundational head-scratcher in physics, some have taken it a leap further, proposing that the one thing that truly collapses the wave is consciousness itself. It has to be said, this is a distinct minority view among physicists. One of the most vocal proponents of this idea is Dr. Robert Lanza, who created a theory called biocentrism. Lanza argues that life and consciousness aren't just random byproducts of physics. They're essential to its existence. In his view, space and time aren't objective things, but rather tools of the mind, a framework our consciousness uses to make sense of the storm of information it perceives. According to biocentrism, the universe is, in a very real way, created by us, the observers. It's a fascinating idea, but it's important to know that biocentrism is seen as highly speculative and doesn't have the experimental evidence to win over the mainstream scientific community. Okay, we are now officially deep in the rabbit hole. If this is making your brain tingle with curiosity and you enjoy having your reality gently shaken, go ahead and subscribe and ring that notification bell. You won't want to miss where we go next. Section 3. Is reality just an interface? Let's take another step into the strange. Cognitive scientist Donald Hoffman thinks our perception of reality might be a complete illusion, but a useful one. He calls it the interface theory of perception. Think about your computer desktop. You see a nice blue folder icon for a file. You can click it, move it, and delete it. But is the file actually a little blue rectangle inside your computer? Of course not. The icon is a user interface, a simplified symbol that hides the dizzying complexity of circuits and binary code. The icon isn't there to show you the truth. It's there to help you use the computer without getting a massive headache. Hoffman argues that evolution has shaped our senses to do the exact same thing. The space and time you perceive, the physical objects you see, they aren't objective reality. They are our species' custom user interface, evolved not to show us the world as it truly is, but to guide our behavior so we can survive. Seeing the raw data of reality would be overwhelming and give us no survival advantage. Instead, we see a simplified, gamified version. This theory, while a cool challenge to our assumptions, is also highly speculative and not backed by mainstream science. It suggests that behind our interface lies a complex network of conscious agents, implying that consciousness is the basic building block of everything. This idea shares some DNA with the philosophical concept of panpsychism, the view that consciousness is a fundamental and widespread feature of the universe. Section 4. The brain, consciousness, and new frontiers. Right about now, you might be thinking, hang on, isn't it obvious that the brain creates consciousness, not the other way around? And you're right. That is the dominant view in neuroscience. We can literally see brain activity light up in sync with conscious experiences. But even here, there are some dissenting voices. Dr. Tony Nader, for example, has proposed the reverse, that consciousness actually creates the brain. It's crucial to point out that this is a fringe position without support from the broader neuroscience community. However, there are more scientifically grounded attempts to link the quantum world to consciousness. The most famous is the orchestrated objective reduction, OR theory, from Nobel laureate Sir Roger Penrose and anesthesiologist Dr. Stuart Hameroff. OR gets incredibly specific, proposing that consciousness comes from quantum computations happening inside tiny structures in our brain's neurons called microtubules. When these delicate quantum states collapse, a process Penrose calls objective reduction, a moment of conscious experience happens. It's an ambitious attempt to give consciousness a physical home in the quantum world, but it's highly controversial. Many scientists argue the brain is way too warm, wet, and noisy for these fragile quantum processes to survive. And these ideas aren't just relics of the past. In 2025, a peer-reviewed paper in AIP Advances from nanotechnology professor Dr. Maria Strom proposed a bold new model. Her theory suggests that consciousness isn't a product of the brain at all, but is itself a fundamental field of the universe, much like gravity or electromagnetism. In this view, a universal consciousness existed even before the Big Bang, and our individual minds are just temporary manifestations of this larger field, like waves on an ocean. Dr. Strom uses the language of quantum field theory to argue that what we call reality is the result of this universal field differentiating into space, time, and matter. While it's a dramatic departure from mainstream neuroscience, it's a serious, mathematically grounded attempt to formalize consciousness as the bedrock of reality. Conclusion: we've gone from the weirdness of a single particle all the way to the biggest questions about existence itself. So, could the universe really be a thought you're having? The overwhelming scientific consensus says no. The story of our cosmos, written in the light of distant stars and the layers of ancient rock, tells us the universe got along just fine for billions of years before any consciousness we know of showed up. For most physicists, the puzzling observer effect in quantum mechanics is about physical interaction, not mental influence. The ideas we've explored, that reality is observer-dependent, a mental construct, or a user interface, are powerful and fascinating philosophical arguments, closer to ancient concepts like idealism than to proven scientific fact. But they are born from genuine puzzles right at the heart of modern physics. Puzzles that hint at the relationship between reality and observation being far stranger than we ever imagined. They force us to be humble about what we think we know. So the next time you look up at the night sky, at the moon hanging in the darkness, ask yourself a question that philosophers and physicists have wrestled with for a century. If nobody was looking, would it still be there? The answer might not be as simple as you think. What do you believe? Is reality a fixed, objective stage? Or is it a participatory story that we help create with every moment? Share your own theories and thoughts in the comments below. Thanks for watching.